Hey gang, the purpose of this video is one of the learning objectives for Math 1500 is that you learn how to use a statistical software package to work statistics problems. And let me see if I can come in on this a little bit. Maybe not. Okay, but what we do is, Shawnee, is we teach you how to use R. And the second R assignment, there are going to be 4 of them. The other one will be, you've already had one on descriptive statistics, which, you know, some of you turned in. And of course, some of you didn't because you're not watching the videos. There's going to be this one. There will be one on confidence intervals, hypothesis testing, and then there will be one on regression and correlation. These are 100-point assignments, too. So you know, good for those of you that turned to me and got the easy 100 points. Now, what I want to do is show you on R how to work these problems. And we've done a little bit of this previously. But at the end of the day, let me get a blank sheet of paper here because there's really just 2 commands that we have to worry about in R. Just 2. And the first one to work these types of problems, let me get sheet of paper going here. The one command in R that we use a lot is called pnorm. And at the end of the day, I don't know why I'm saying that so much, pnorm corresponds to the normal CDF key that we use in our calculator. And if you've been following the videos, you'll know that I called this the P key for a reason, because this key works problems that ask to find things that start with a P. Probability, proportion, percentile, and what's the other one? Probability, proportion, percentage. If you're being asked, now it's not that the problem includes those words, but if you're being asked to find something, if you're being asked to find a probability, if you're being asked to find a proportion, if you're being asked to find a percentile, if you're being asked to find a percentage, you use this key. Hence, in R, you use the pnorm. Now, the other key that we run into in on your graphing calculator is inverse norm. Guys, remember this has 4 things that we have to put in, and this has 3. The mean and the standard deviation are always the last 2. Okay. Now, the inverse norm key that the R key that corresponds to the calculator key of inverse norm is called Q norm. So what happens down here with inverse norm? We are trying to find a score from the distribution that has a given probability, given proportion, given percentile, given percentage. It's given this information. We're not looking for it. We're trying to find the score from the distribution that has that particular characteristic, let's say. Now, let me give you an example of the difference. Guys, I need to get a sheet of paper here. If I can find a sheet of paper someplace. Yeah, here's one. Now, an example of the 2 types of problems that we run into, and they come in all different shapes and sizes, but if we say something like, you know, IQ scores follow a normal distribution of a mean of 100, standard deviation 15. If I ask you what IQ score represents the 80th percentile, what key am I going to use? Well, guys, I'm not asking you to find a percentile. I'm not asking you to find a probability. I'm not asking you to find a percentage. Nothing that starts with a P. This information is given. I'm asking you to find a score from the distribution that has this characteristic. Therefore, you would use the inverse norm key on your TI-84 you would use the Q norm key on R. All right? Now, what if we say, what is the probability a randomly selected person has IQ greater than 130? What is the probability? I'm asked to find a probability here. So guys, what you're going to think is you're going to think the P key. If we're using our graphing calculator, then you'd use the normal CDF key. In R, you're going to use P norm. All right, so guys, it's going to come down to using two keys, either Q norm or P norm. Now, let's talk about what those keys do for us, okay? P norm has three values. It has the score, it has the mean, and it has the standard deviation. This always gives area below. Now, so you might say, well, what if we want area above? If you want area above, then you have to go 1 minus P norm of the score you're given, the mean, and the standard deviation. I'm going to illustrate that in just a second. All right, Q norm works exactly like inverse norm. Has three things: area below. And you might say, well, if you got area above, then you subtract it from 100. Mean and the standard deviation. This works exactly like inverse norm. So if you can remember that if you want area below, you just put in the score, put in the mean, put in the standard deviation, you're done. If you want area above, you just take that value and subtract it from 1. And if you want a score from the distribution that has a particular area below given or can be figured out, then you use Q norm. Now, the best way to figure this out is just start to work some problems. And that's what I've got here. I've got some problems that I want to work and show you how we do that. And I think you'll find out, if you approach this with an open mind, I think you'll find out that R is, let me get this situated right here. R is easier to deal with, I think, than the graphing calculator, because you don't have to worry about any of that negative E99 or E99 or which comes first, what goes second. It's always straightforward. You just put in your score and you get the answer below. And if you need above, you just subtract it from 1. So we're going to work problems here with the normal distribution and the central limit theorem, sampling distributions. So gang, problem number 1 says the distribution of gestation period for pregnant adult females is normally distributed mean 266, standard deviation 16. A person is selected at random. What is the probability that her gestation period is less than 270? Man, that is so easy. P norm 270, mean 266, standard deviation 16. We're done. 0.5987. That's all you got to do. Now, what if it had said, what is the probability that her gestation period is more than 270? Well, then you just have to subtract that from 1. And get 0.4013, okay? But it didn't ask that, it asked below. Okay, part B, a random sample of 50. Now, guys, when you think about 50, you need to start thinking we're dealing with a mean for those 50 people, so we're talking about the central limit theorem. And what's the only thing different in the central limit theorem? The standard deviation has to be divided by the square root of n. All right, so what we got here? What is the probability their mean pregnancy duration is greater than 265? Well, guys, I know I got to subtract from 1. And I know my score is 265. I know my mean is 266. And I know that I have to adjust the standard deviation of 16 and divide by the square root of the sample size, which is 50. So the answer here would be 0.6707. Cool? I think so. I think it's easier. Just remember again, less than, just put in the score, put in the mean, put in the standard deviation. Greater than, subtract from 1. But you still put in the score, the mean, the standard deviation. But when you take things more than 1 at a time with these types of problems, you have to divide by the square root of n. Now the next thing says, what mean gestation period for 100 pregnant adult females represents the third quartile? Well, guys, what you're trying to do now is you try to come in and you're trying to find the mean that has 75% below it. Because, guys, that's what the third quartile is. It's the value that has 75% below it. So, guys, in this situation, you're going to use Q norm. You're not asking to, you're not being asked to find a percentile, a proportion, a percent, anything that starts with a P. You are given the information and you're trying to find the score from the distribution that represents the third quartile. So we want 0.75 below. We want the mean. And we want the standard deviation. And guys, remember, if we take these things more than 1 at a time, we have to take divide by the square root of the sample size for the standard deviation, which we call the standard error. So I've got 100 of them. So I've got to come in and divide by the square root of 100 for mean problems. Now, when we get down here to this percentage, it's a different type of problem. Different type of tool is required to work those problems. So we wanted, there's no above or below here. It's just you got to put in the percentage below in the problem. So you'd need a gestation period of about 266. I'm sorry, 267 to represent the 62nd percentile. 267.0792 to be exact. All right, gang, number 2. At a large grocery store chain that has stores across the country, 72% of its shoppers are women. Now, guys, it's a different type of problem. This is a problem that brings in P. We have to worry about P hat. We have to worry about, N times P, different things. It's a different notation as we've studied ad nauseum in previous videos. So what we do is we still think about what key do we use, Q norm or P norm. And since we're asked what is the probability, so if n equal 400 shoppers are selected at random, then what is the probability that more than, well, guys, that more than says what? We got to subtract it from 1. And since I want probability, I know I'm going to use P norm. All right, what's my score? 75%. Well, no, more than 400 shoppers, so we want more than 75, so I need 0.75. The mean for this type of problem is N times P. And the standard deviation is the square root of N times P times 1 minus P. So I have 400 times 0.72 times 1 minus 0.72 is 0.28. All right. So that's kind of weird. probability that more than 75% of its shoppers oh, wait a minute, gang. I did that wrong. That's scary. For these types of problems, I have to use the mean of P. Well, that was scary. If I have the count out here, then my mean is N times P. But if I have the percentage, then I have to use that the mean is equal to P, and the standard deviation is P times 1 minus P over N. So I need the square root of P times 1 minus P divided by N, which is 400. All right, much, much, much better. Now, I've got a problem here in a minute where I'm going to demonstrate where you can do this. Because you can't use this. This is a count. If we had a count there, if we had like 320 women, we'd have to use the, either 320.5 or 319.5, depending on above or below, and then we'd have to use that mean. So I was actually, to be honest with you, somebody is in my backyard working on my. We have a community-wide septic system down here where I live. And I got sidetracked because I'm trying to figure out what the heck they're doing in my backyard. So, and I see now they're working on the control center. So, good for them. But they got me sidetracked and I almost missed the problem. All right, let's look at this one. If n equals 400 shoppers are selected at random, then what is the probability that less than 290 are women? Now, guys, remember less than. We get to use just P norm without the 1 minus, but less than, we have to take the limits of 299.5 and 300.5, as I've talked about in the previous video, and less than, we concentrate on the lower part. So because of this less than, I don't have to do 1 minus, so all I've got to do is just use P norm. I'm going to concentrate on the 299.5. The mean is N times P, which is 400 times 0.72. And the standard deviation is the square root of N times P times 1 minus P. And our answer would be 0.8998. All right. Part C, what sample proportion represents the first quartile? Now, sample proportion tells me that I want some P, which is going to be not a count, but a percentage, which we're going to let be a decimal. So I need to use not this notation, but I need to use the notation over there where my mean that I used in problem A, where my mean is equal to P and my standard deviation is equal to the square root of P times 1 minus P all over N. Now, if that's a little bit confusing, you need to go back and watch one of the videos because I taught this to you multiple places. But at the end of the day, when we're talking about a percentage or a proportion that we're examining versus a frequency, this would be 280 women. This would say that 72% of women. So if I'm focusing on a percentage as the value I'm calculating the percentage or proportion of, then my mean is equal to P and my standard deviation is equal to P times 1 minus P over N. If I'm calculating a frequency, then my mean is N times P and my standard deviation is the square root of N times P times 1 minus P. Where are you living? Which one are we talking about? So again, back over here, we were talking about a percentage. So I had to have my mean of P, standard deviation. Okay? Right over here, we're talking about a count. So I had to use my mean as NP and my standard deviation as N times P times 1 minus P square root of all that. All right, so we got to see what we're talking about. So since we're talking about a proportion, I'm living over here. And also, since I'm talking about a proportion that has a particular characteristic at the 25th percentile, then I need to use Q norm. So 25% represents the first quartile. My mean for this type of problem is just P, which we know is 0.72. That's given in the problem. And my standard deviation is the square root of 0.72 times 0.28 divided by the sample size, which I guess we're assuming is 400 since that's been consistent through the problem. So guys, the sample proportion would be 0.7049. And you got to think if we actually do have 400 shoppers, then you could take that times the 400 and get a count. So you're talking about 282 customers. So what do we want to talk about? Percentages? Or we want to talk about counts? These are the same thing. They just use different notation in the way you work the problems. All right, gang. Number 3, in 1990, the magnitude of all earthquakes in California that measured 0.1 or higher on the Richter scale was normally distributed with mean 6.2, standard deviation 0.5. Wow, I even give you a source. All right, gang, so what percentage of earthquakes has magnitude between here? So we're looking at percentage, right? So we know we're going to use P norm. But I threw something at you a little bit different here intentionally. I threw something at you here that did between. Now, how do we handle that? If we got 2 scores here, and we want the area between, not just above or below. Well, what we got to do is we've got to find the area below of the biggest one, come in and subtract out the area below of the smallest one, and that'll give us the area between the two. So guys, I'm going to go P norm, 7.1, comma 6.2, comma 0.5, and then I'm going to subtract out P norm, 5.8, mean of 6.2, I'm sorry, and 0.5. So the area between that will be 0.7522. Make sure I didn't make a typo. 7.1, 5.8, yeah. So these values, this is the value I used in the first part. This is what value I used in the second part. All right. Now, next problem. I've got 36 earthquakes. So guys, I'm thinking about the mean again. So I've got to divide the square root. I'm sorry. I got to divide the standard deviation by the square root of the sample size. So our selected, then what is the probability their mean is between 6 and 6.2? Well, a lot of the same principles that we work this problem with apply down here because we're looking at between. We're going to take the area below the biggest. And remember, we've got to take the standard deviation divided by the square root of the sample size, and the sample size is 36. And now we got to come in and do P norm of the smaller number, which is 6.0, mean of 6.2, standard deviation 0.5 divided by the square root of 36. So gang, our answer would be 0.4918. Guys, remember, you're all's, I put up a video earlier about, information for the week, and that tells you when your R assignment is due. So if you didn't watch that, you need to go back and watch it so you get this thing turned in on time. Now, what is the percentile ranking of an earthquake with magnitude 7.5? Starts with a P, right? We're trying to find something that starts with a P, so we know we're going to use P norm. So P norm again, percentile ranking is just the percentage below. So I just put in my score, put in my mean, put in my standard deviation. It doesn't say what's the percentile ranking for, n equal 50, the sample mean for n equal 50 earthquakes. It just says one of them. What's the percentile ranking for that particular earthquake? So I don't have to divide by the square root of the sample size. The sample size is 1. So this would be at the 99.5th percentile. Now contrast that problem, which is asking you to find percentile ranking, which was nothing more than percentage below, with this one. This is what earthquake represents the 80th percentile. So what we're wanting here in this distribution of earthquakes, we're wanting to find that particular earthquake. That has 80% of the area below it. Well, guys, you should know by now that's a Q norm problem. So 0.80 or 0.8, either one. Mean, standard deviation. So an earthquake of 6.62 on the Richter scale would represent the 80th percentile. Now, I find it really interesting that these earthquakes turned out to be normally distributed. I wouldn't have thought that. I would have thought that they would have been severely positively skewed. Let me explain why I feel that way. I would thought that in a year like this that you would have a lot of tremors and a few kind of minor earthquakes, and I would have thought over the year, that you would have very few earthquakes of high magnitude. So the fact that these are normally distributed is a little, I question that. I have no reason to question the United States Geological Survey, but I would have thought this distribution would have been positively skewed, but apparently not. And if it had been positively skewed, we can't work the problem because of that norm thing there. That Q norm requires you to have a normal distribution. Guys, your assignment will be posted very soon. It's separate from the Hawks, so make sure you get that to me by the due date. It'll be on Blackboard, and it'll be in this particular week. So pay attention to it. Get it in on time. Take care. Bye.